All right, ladies and gentlemen, hello and welcome back once again to the longest running show in the world about data. It's DM Radio. Yours truly, Eric Kavanaugh here, year 17 of the show. And we're at Current in Austin, Texas. And folks, I'm very excited to have a couple executives from Citizens Bank. I know Citizens Bank. I'm a customer of Citizens Bank. I've been very impressed with the customer service they've had, and they're doing very cool things with Confluent. From what I understand, they're in striking distance of being the first commercial bank in the United States to be completely in the cloud, truly cloud native as well, a multi-cloud, hybrid cloud for the time being strategy, but going multi-cloud, that is so cool in so many ways. First of all, redundancy, resiliency, but also the ability to do comparison and contrast of which environment is better for which kinds of workloads. How do you get better service from this one versus that one? All these things come into play if you are truly cloud native. Not an easy thing to pull off. You really have to think through the architecture, the apps, how they're going to get their data. And that's where Kafka comes in and Confluent. So, folks, I'm very pleased to be with Anand Vijai and Sudhakar Gopal. So I'll throw it over to Sudhakar first, maybe. Tell us a bit about how Confluent and Kafka in particular play into your multi-cloud strategy.
So we've been working and partnering with Confluent over the past 3 years. We didn't have an on-prem version of Confluent Cloud through one of our acquisitions. So we didn't have a little bit of background with Confluent prior to that. But at scale, we started working with Confluent over the past 3 years. The adoption of Kafka across the organization has been growing exponentially. We've enabled about 35 odd use cases, of which about 20 of them are actually in production, are live. One of the key use cases that we've been working on is offloading data off of the mainframe. Obviously, there is through our digital transformation that we are going through, there is a strong need to improve the performance of the APIs. So Kafka has played a huge role in that. The other area that we've been working on is customer communications, event-driven architecture, alerting, whether it's for fraud alerts or for other kind of communication that we do with our customers. Again, Kafka has a huge kind of a role to play in that.
Yeah.
And Confluent has been a great partner.
35 use cases, 20 in production. Anand, I'll throw it over to you. That is pretty impressive. I think you have 19 to 20 more use cases in production than many banks. Can you talk about how you got here and what impresses you most about a streaming platform and going down the streaming road, which of course is very different from traditional batch jobs, ETL, all these ETL batch windows having to be hit day and night and day and night. What do you think about all that?
No, I think, yes, Sudhakar mentioned, we started our journey 3 years back with Confluent, and the timing was actually, really good in the sense that we also started creating an enterprise data strategy. And when we looked at the blueprints of all of the different line of businesses that we support, we came up with 6 different pillars that we wanted to focus on to kind of advance citizens' data strategy. One of the pillars is batch to real time. So that was very significant. I think it took a lot of time and effort to try and articulate what batch to real time meant for the organization, because it involved changing the mindset of our business partners, our engineering leaders, as well as our engineers, because we had to take them through a learning journey as well. And we also paired that with another initiative that our CIO was driving. We call that NGT, or Next Gen Transformation, which was started 5-6 years back. And one of those tenets within the NGT was to basically build engineering within the bank. And we ended up creating learning academies and badges. And we created those badges and learning academies for both API as well as Kafka. So that really helped immensely, because what started happening was the engineers on the ground started thinking organically about how we can stream or how we can actually operate on data as events rather than batch files. So I think those 20 and then the 35, and we obviously want to double and triple over the next couple of years, is largely due to the combination of both our data strategy being focused on batch to real time, as well as enabling the organization itself to operate that way. And I guess both from API and Kafka, even from an API standpoint, Sudhakar, I think we made a good progress in terms of setting up our own OpenShift. Right. So I think that's kind of how we've been able to achieve that.
Yeah, well, it's a next generation information architecture, and that's really what streaming platforms were all about, right? And it was designed, of course, at LinkedIn as Kafka, the engine that runs LinkedIn, a messaging service that would allow you to move information from here to there or there to here without worrying about the orchestration overall, right? Just get a flow of information, and it is very fluid in that sense. So, Doctor, would you agree that a lot of the value from a streaming architecture comes because the data is constantly in motion and you can access it as needed, tap into that stream, if you will, pull it into your app or into your use case and do what you want with it, right?
100%. The ability to kind of propagate key events and key data across the ecosystem is critical, right? So, taking an example, when a customer changes a name or an address or a phone number or any of the attributes, customer attributes through a digital channel, it used to take us several days to propagate those changes through the ecosystem. Today, we do it in a matter of seconds. We are able to publish that event through the entire ecosystem in real time.
Wow.
And that is extremely powerful.
Yeah.
Because that in turn drives customer experience. So we have several such examples, catching fraud events in real time. And what used to be more a predominantly batch process, that we run overnight batch processes to identify patterns. We are able to do that in real time, in motion right now, as the data is moving through the ecosystem.
Wow. And the customer experience part is really important too, to your point, because customers just want things to be right. If I update my information, I want to come back an hour later and see that it's updated, not realize that it's updated here, but oh no, sir, that's not what we have in our system now. That's not what we have in our records. You get this cascading effect of bad experiences across multiple departments if it isn't done right away. So now it's done at once, it's done everywhere, and the problem is solved, right?
100%.
Yeah, I just think about the engineering time. Each one of those touch points in the old-fashioned way, someone has to go do something. And if that person didn't get the memo on time, or this person isn't at work today, or this person misunderstood what was requested, any of those things come into play, and all that goes out the window when you embrace and then effectively install a streaming architecture, right?
100%.
For sure. Yeah, I think, if you just take that same example even further, right? It's the power of streaming is that you can now kind of blend both operational and analytical worlds, because you don't really have to,
Interesting.
in the historical sense, right? Like, we had to basically treat operational processes and events differently to analytical events and processes differently, because, again, the operational platforms would operate real time, because obviously they have to provide that real timeness to the customer and the
Right.
experience. But then we always took a laid back approach to getting the data for analytics. I think, as you saw in the keynote as well as in the sessions over the last 2 days, that world is getting closer and closer, and a lot of the outputs that are coming out of your analytical ecosystem is now expected to be fed back real time for operational users to be more effective, operational processes to be more effective, which again is really possible if you have a strong event-driven architecture that is anchored on streaming as a capability. I think that's really where the power as well is, because if you as a customer are performing an activity and that activity is made available within a few seconds for your analytics to react,
Right.
and it's producing an insight or an alert, and that's fed back to the operational platform, and that happens within a few seconds, I think that's significantly different than how we would have approached it maybe a few years back.
Well, sure. And just think about the time and effort. I mean, I've been in this business a long time, and I remember the history of data warehousing is companies realized you really could not run analytics on an ERP system, on an SAP or
That's right.
something. And so what we had came up with was a plan to pull the data out of all those systems. Those are the batch jobs, load it into a schema in a very expensive Teradata warehouse. You can't change that schema without tremendous pain back in the day, right? So then you're stuck with this schema, but it still becomes very effective at a slow pace with a lot of latency. But the point you're making, I think, is really compelling, because OLTP versus OLAP, well, transactional versus analytical, they've been two separate worlds. And then you have to find ways to infuse the analytics back into the operations. That's been a very slow process. for years, it was also a relatively offline process, meaning some analyst would analyze all the data, come up with an idea, and then send an email or send a proposal to an operations person who would say, leave me alone, I'm busy doing the work of the business. Like, why do you want me to change anything? It was hard to do, whereas in this new event-driven architecture, that's not hard to do at all. Now you can have the insight, as you suggest, in seconds coming in. So you could determine, uh-oh, this customer is about to churn. Bing, send them a little message, say, hey, thanks for your business. We'd like to offer you a discount or some special promotion. And you can do that in near real time, right?
100%. So we are seeing a lot of improvement in our customer experience in our servicing channels, especially the self-service channels, because now we are able to quickly get the data to those self-service channels, wherein what used to be a walk into a branch or a phone call, a lot of that has now been automated, you know. So to Anand's point, the lines are blurring now between operational and analytical workloads that we are doing. We're also pushing the envelope there. And so if you look at our data lake, we have about 6 petabytes of data in the lake. What used to be kind of a very slow and batch process, today now we have enabled, you can consume data from our lake through APIs, through streams, and you can push data into the lake in real time as well, or near real time as well. So going back to our customer MDM example, as the attributes in the MDM change, we are actually not waiting for a nightly batch process to push the data into the lake. We are actually streaming it to the lake simultaneously. So that's where I think Kafka has been extremely powerful.
Well, this is 10 years ago when I interviewed Jay Krebs the first time. This is what really fascinated me about the streaming architecture, is that you set up a topic, it's a stream of data about a particular, let's say, customer experience or transactions that are occurring right now. In the old world, you'd have to individually move it here to there, here to there, here to there. In this world, it's a one-to-one or one-to-many. And anyone who wants that stream can subscribe to that stream and ingest the information and gets it at the same time that all the other systems get it. So now you have a concurrency running throughout the entire organization of relevant information, right?
Yeah, I think, in the batch world, we used to use the term called single sourcing. If you have an operational platform that's producing data for you, you want to get one copy of the data, make it the best copy possible, whether it's financial accuracy or data quality, and make that available for everybody to consume, which was very hard to achieve because a lot of systems applications would go and consume them individually. So you will mostly end up with multiple copies of that data, right? So in the event-driven architecture, it's your paradigm has shifted because that one single copy of the data is sitting in that Kafka topic, to your point, produced by a single producer. But then there could be, 1, 2, 3, or many consumers operating on that same event with a very different lens for a very different business process. And you don't end up with the historical problem of what we would call as data duplication or data proliferation, right? So I think that's very powerful for sure.
Yeah, that's an interesting point too. So in a legacy architecture, you wind up with many copies of data. And there are lots of valid reasons for that, because someone wants to run analytics over here, someone wants to do a pet project. But in this new world, again, you could be feeding developers, you could be feeding marketers, you could be feeding administrative people, accounting people with the same data stream. So they're all seeing the same thing. They just have a different lens that they put on for seeing which part of that matters to them, right? What do you think about the governance stuff? I was very impressed at hearing about this shift left strategy around data governance, solving data governance problems way, way, way upstream, so you don't have error propagation and everyone gets the right data. How did they do that? What's the teeth in that data governance? How does it actually work from your perspective?
It's a great question, because we've been actually working with Confluent very closely on the journey, on the stream governance journey. Some of the features that you see are also, I would think, requirements that we have basically made as an ask to Confluent as well. So I'm very happy to kind of see the trajectory that they're taking the entire stream governance capability.
Yeah.
Some of the capabilities like the tagging, which they currently have added, and the ability to attach what I would define as a security measure. It could be an encryption or a tokenization or an obfuscation technique that you want to apply on. They've enabled that as part of the streaming ecosystem. And I think what's even more powerful is that they've not just enabled that, but they've also basically allowed you to interact with that through APIs.
Hmm.
Again, that's the power where we can basically communicate with Confluent using their API stack and really set tags, manage those tags, set up measures, set up encryption routines. That gives a tremendous power for our data governance organization, not only to implement governance, but also be able to kind of demonstrate governance, right, end to end.
Mhm.
So they, I think that's a great kind of move towards the right direction. There are also, I think, more features upcoming, we believe, and we will continue to work with Confluent to make sure that whatever lens that we can bring in from a finance industry standpoint, because obviously, as you know, we are pretty much governed and audited
Yeah.
uh, more than most other industries. So I think it's really important that we partner with them and get the features implemented in a way that will help us
Yeah.
meet governance requirements.
Well, and you solve a lot of those government's requirements out of the box with this kind of approach, right? If you, as I often think
Yes.
about the job of an auditor or a regulator, it is not an easy job to go in and examine some production system and try to do the math in your head of, okay, how does this go here and that goes there? I mean, a lot of companies don't even know how some of that stuff works, right?
Absolutely.
And so if you have this kind of a very clean architecture that makes your job easier, it makes the auditor's job easier, right?
Yeah, think of the moment a topic is created and data is being produced, and the second somebody starts consuming it, you already are able to see the lineage. It's pretty much real time.
Mhm.
So you not only get data real time, you also get lineage near real time,
Right.
which is significantly different than if you would recall in the batch world, people would have to sit and create data mapping documents.
Right.
But the moment they save the document,
Something
it's stale.
changed. Right.
Yeah. So it's a lot of overhead to keep up with the governance requirements. So again, this is a great step in the right direction.
Yeah, and truly cloud native, right? So
Right.
you have to really think through your architecture and how the apps work and how everything works. But once you're cloud native, then you're not locked into any one particular cloud. You can move around, you can do different things. You give yourself a lot of flexibility. Real quick, final comment.
Yep, we're very, very excited. I mean, like I said, the adoption has been growing exponentially across the organization, and we are seeing a lot of benefits and improvements in our customer experience. So very excited.
When the customers are happy, everyone's happy, right?
Thank you.
The customer is always right. That's what they say. But folks, look these gentlemen up online. Citizens Bank. We've been talking to Anand, Vijay, and Sudhakar Gopal. These folks know what they're doing. Streaming architectures are the future, and they're going to save you. They're going to save you time at the bank. They're going to give you a better experience. They're also not going to lose your money. Of course, that's very important as well. And hang on, folks. You are listening to DM Radio. All right, folks, welcome back to DM Radio. Yours truly, Eric Cavanaugh, here with Ryan Wright of thatDot. And Ryan is the CTO and founder of this company. And this is a very interesting company, folks. We're here, of course, at the current conference. You just heard from the gentleman from Citizens Bank, where they're doing all kinds of really interesting work with Kafka, real-time data streaming. One of the things that is a real challenge in this world is dealing with threats, dealing with bad actors, and also just being able to do analysis on complex data as it moves through the system. So traditionally, you persist data, then you do analysis on that somewhere way down the pipeline. That may be the next day, the next hour sometimes, or the next week, depending upon how complex the data is. But if you want to catch bad actors or you want to catch bad things happening and solve problems in real time or near real time, you need a technology that's going to be able to absorb that information and allow you to run queries persistently on moving data. So that's streaming analytics. And what thatDot has is a streaming graph. So graph has been popularized by Facebook and LinkedIn and these other companies. They help you understand who knows whom, and that allows you to understand ecosystems. It's very useful for understanding how lots of different parts come together to create a whole. Well, what thatDot does is allow you to analyze streaming data and even very, very complex streaming data. So advanced persistent threats, for example, which can sit inside of an organization for 6 months. I think that's the average, 6 months. They just wait and hibernate until a time window passes, and then they kick in and they do their bad work. Well, that's not a problem for thatDot. So Ryan, Wright, tell us a bit about streaming graph and how you're able to solve some of these previously intractable problems.
Yeah, Thanks, Eric. It's, as you mentioned, the graphs are really powerful in their ability to connect the dots, to put pieces together, to understand deep relationships in data. And graphs have been around for a while, but they've kind of built a reputation as being neat, cool, good to look at, and very useful, but slow.
Right.
Our team has really been working over the last 10 years with research that began in DARPA and focused on some really critical cybersecurity challenges, like you'd mentioned, to create new graph capabilities that can operate at modern data volumes and modern data speeds.
Right.
So data isn't slow and static anymore. Data is moving and it's flowing, and answers now are always better than answers later.
Right.
So the challenge has always been, how do you get answers to deeper questions? And how do you do that fast? It used to take creation of big data pipelines, lots and lots and lots of custom code to do very handcrafted approaches that could maybe scale to handle some deeper questions. So this is like Google scale and Facebook scale kind of work. But now almost every enterprise has those same kind of deep questions that need to be answered. They're questions about fraud, they're questions about cybersecurity, and it's latent in the data, but you have to do this deep processing to get those answers.
Right.
So we created the world's first streaming graph. It's the benefit of that deep analysis that you can do on a graph, but able to run at massive scale, millions of events per second, and can run in the stream.
Right.
So it doesn't have to be this slow end of the line process anymore. It can plug right into Kafka, right into the source of data that's happening in real time, and turn those into real-time answers with all the deep context that you need from a graph.
Right. And what's so interesting here is that, again, traditionally, you would have to wait for data to be persisted somewhere. And then for those deeper, more complex problems, you're running analytics of various types to figure out, okay, was this normal? Is this not normal? What you really want to be able to do is catch bad activity as it's happening. So as the data is flowing through the network, for example, everyone understands how a network operates. You connect your machine to the network, you get online, you start asking questions, IP addresses are flying around, user behavior is occurring. Well, if you have a streaming graph, such as thatDot, in the stream itself, as the data is coming through, you can have some very complex queries that you've built over time running constantly, such that if a weird pattern of behavior shows up again, you know instantaneously, aha, this is that phishing attempt that we saw 2 weeks ago, here it is again, and trigger some action and solve the problem now. You don't have to wait till tomorrow or 2 hours from now. You solve it right when it happens. And you can even dynamically adjust the graph when new factors or new concepts, new nodes, new behavior shows up that you haven't seen before, right?
Yeah, that's exactly right. A lot of times the key piece of the puzzle that you need to understand a cyber threat, for instance, the key piece of the puzzle isn't one piece.
Mm-hmm.
It's built out of many little observations that are made through the stream over time.
Mm-hmm.
And a traditional approach would take and plug some tools into that data stream, look at what's happening within a certain time window.
Mm-hmm.
And that time window is usually based on how much RAM you can afford. So how much memory is on the machines that are doing the processing. And so you might have a time window of 5 minutes or 10 minutes or an hour or 3 hours, just depending on your data. And that time window is now the limit for what you can detect.
Right.
Because you can't hold the whole world in memory all at once.
Right.
So you've got to choose. So data engineers typically say, well, let's look at the most recent data, hold that in memory and try to put the pieces together. Because the pattern that tells us about the bad guy's activity is built out of many of these pieces.
Mm-hmm.
So putting the pieces together, if they show up within the time window, okay, great. You can use those traditional tools to find it. But if one of those pieces falls outside of that time window, you'll never detect it.
Wow.
You won't see that activity. And the cyber threat turns out to be something you report on, we were breached, 6, 8, 12, 14 months ago.
Right.
Instead of having the data come through in a way that you can understand in real time and say, we're being breached right now, let's stop them.
Yeah. Well, and let's put this in the context of financial services. We were talking to Citizens Bank in the previous segment. You've got lots of branches around the country. You have all this activity online. all of a sudden something from one branch just doesn't look right. It's a different flow. Maybe there's an employee who's logging in from a different time period than he normally does and is doing a lot of activity when normally it's a little bit of activity. That would be a difficult thing to detect with traditional tools. But again, if you have this streaming graph where you're monitoring information as it's flowing, you're going to catch right away that there's something going on here. This is not different. It warrants attention at least, and then be able to quickly ascertain, okay, this doesn't look right at all. Let's shut down that process. Don't allow this person to keep doing what they're doing and investigate, right?
Yeah. Graphs are this really powerful tool, especially being able to monitor them continually for patterns like that. So if you know to watch for those kind of patterns, you can find them in real time now with a streaming graph. But even more than that, the streaming graph is a foundation for the next tool that our team has built as well. We call it novelty. It's the ability to plug into a stream and understand for everything that's happening in real time, how novel, how unusual is that event compared to everything that's come before it.
Right.
It's like anomaly detection, but it's extended further and faster and better because it looks at the whole context, especially using categorical data.
Interesting.
So most anomaly detection has to take numbers as input, and the methods that data scientists have for turning non-numeric data into numbers causes anomaly detection to perform worse and worse and worse.
Right.
It's known as the curse of dimensionality.
Oh, interesting.
So that prevents anomaly detection from being useful for finding those kind of behaviors like you're describing, that bad activity in one branch of the bank that just occurred. But if you plug a novelty detection system like this in, it can look at all the categorical information about what user, what time of day, what activity, from what system, from what location.
Right.
Those aren't numbers.
Right.
They're categorical values.
That's right.
And they give us context about understanding what's, who is it? What are they doing? What's relevant? And when we fold all of that together, it uses the streaming graph under the hood, but it turns it into a total ranking of everything that's occurring and how novel, how unusual it is.
How interesting.
So you can prioritize and understand in real time what's strange, what's happening. Even if there's something brand new you've never seen before, sometimes seeing something new is normal. And novelty detector can use that graph under the hood to understand all that context, to understand when something brand new is normal versus when some activity is suspect and should be alerting someone about it right away.
Yeah. And let's go again with understanding the network and then people, right? So there are different people in organizations. There are different roles in organizations. A lot of times these technologies will tap into Active Directory or LDAP or something like that to ascertain permissions, who should be able to access this or that, who should be able to make a firewall setting change, for example. These are the kinds of factors that go into understanding how novel is this, how normal is this, and how serious is this, how severe is this? Not just novel, but it's severe. So all of a sudden there's 2 new employees at this branch and a firewall has been changed and there's more money flowing than there usually is. All of that can be detected in real time by a streaming graph, right?
Yep. Yeah, that's exactly right. But it relies on this ability to connect the dots. You have to put the pieces together.
Right.
So your user record in Active Directory tells you something, but it needs to be combined together with, say, what's happening on the network right now.
Right.
The record tells you what the user should be able to do. The activity on the network tells you what is happening.
Right.
You have to put those pieces together and connect those dots to actually see the big picture.
Right.
And so it's great for banks and other kinds of companies to start adopting these key capabilities that let them stream data in, that let them pull their data together and operate in the cloud like this. But the next step of the puzzle, the next challenge is, how do you actually understand what's happening?
Right.
And how do you do it fast enough to matter?
Right.
Because if you're streaming that data in and then it's just going into your data lake, and you've got some ETL tools bolted on, then you might find out that a bad guy's doing something in a branch office a day or 2 or 3 or 5 later. And by then it's too late.
Yeah. Well, and I had a conversation yesterday with a gentleman who was talking about how good these Gen AI engines are getting at mimicking voice authentication. So if you can mimic someone's voice perfectly, then you can access their account if voice is the only way they get into their account. And what I suggested to him is kind of what you're alluding to, which is that you're going to need more and more data points around any given action or interaction in your environment to know if it's strange or not. So someone has mimicked the voice of the chief financial officer, is trying to log in, but the location is strange and it's not the computer he normally uses, or the behavior just doesn't look, it doesn't have the signature of what that user normally does. So I think you're going to need these kinds of technologies to have additional data points and to be able to connect them in a meaningful way and then run that filter all the time on the data as it's moving through. What do you think?
Yeah, AI is changing our lives right now. It's amazing what can be done in these systems. Some of that is revolutionary for the good, and some of that is revolutionary new capabilities for bad guys too.
Right.
And so if you think about, how does a human actually trust another human?
Right.
How do I
Right.
know whether to trust you or not?
Right.
And it's based on so much context.
Right.
About, right now we're here together, we're physically, I can poke you and touch you and know that you're here for real.
That's right.
But it's like one person trusts another because of the context and everything related about your interactions, your history, the subtle things about your experience that usually we take for granted, like being together physically.
Mhm.
And those are context. Those are additional signals that a lot of times we just factor in unconsciously or subconsciously. And for a computer system to do that, it means you really need to connect those dots. You need to pull in those signals. The real-time nature of those is really important. And you need to stitch them together so that you've got that whole context for a computer to work from as well.
Right.
And while AI can do so many amazing things, one of the interesting research results coming out of Google research and a number of other places is that what AI is bad at tends to be what graph systems are really good at.
Oh, interesting.
That sort of connected, purely logical reasoning, where you can know for sure that these two events are connected and how they're connected with confidence and logical certainty. So being able to turn that into the kind of connected context with logical certainty is the complement to how to make use of these powerful AI systems that are more probabilistic in their reasoning.
Yeah, no, that's a very, very good point. And what you're doing is you're grounding these new systems, because to your point, all these Gen AI things are probabilistic. They're all probabilistic. They are not deterministic. So with a streaming graph, you're able to get a view of the world, amend that view of the world over time, and then consistently persist that query on the data that's streaming through your environment. So anytime any of these weird behaviors you've seen so far show up, you can catch it, you can take action on it. And if something completely novel happens, you can also jump on that and take care of that in near real time, right? 30 seconds.
Yep. That's the two sides of the coin, really. It's connect the dots, plug into streams, and do that deep reasoning all together in the stream in real time. And so if there's patterns you're looking for, you can find those patterns immediately while the data is flowing through. And the other side of that coin is, if there's things you need to find that you don't know to look for, you don't know the patterns to watch for, novelty detection is exactly the kind of tool to find those unknown unknowns, the things you didn't know to look for. Find them, rank them, and tell us about them immediately.
Right. And that's great stuff for business analysts too. It's not just for security. I mean, I get excited about anomaly detection, discovery. I get excited about finding new patterns in the business, new opportunities for new lines of business, for example. So this is not just for threat detection, but it's very, very good for threat detection. Look this gentleman up online, Ryan Wright of thatDot. We'll be back in a minute. You're listening to DM Radio. Okay, folks, back here on DM Radio. What an interesting show so far. We talked to Citizens Bank, we talked to thatDot, and now we've got Sanjeev Mohan of SanjMo, who is one of the best analysts I've come across in my days. And he's been around for a while watching the market. And he's got a very interesting take on streaming versus batch. Of course, batch-oriented, persisted data, that's the old way of doing things. And Sanjeev, you just said something really compelling as we were chatting before this segment recording began, and I'd love for you to say it. So tell me about streaming versus batch.
So what I was saying, Eric, was that streaming is real life, batch is not. Batch is actually a casualty of how the original computer systems were designed and built. They were like super expensive. So processing data in real time was a luxury. No one wanted to spend that much money on it. And that's why we went to batch, because you could do, nightly data processing. But the problem with batch is that it's all after the fact, which means that, let's say, somebody has stolen a credit card and is abusing it. You want to catch that fraud in real time, not at night when you do your reconciliation.
That's
And
right.
so this is why, but we couldn't do it. In fact, I would say that because streaming is mainstream, batch is actually a subset. It becomes a use case of my streaming data. Streaming data is
Mhm.
unbounded. It's always coming. But if you say that, you know what, I'm going to put a start and an end date into that stream and process it, then that becomes batch. So batch becomes a special use of streaming data instead of thinking it the other way around. So we
Right.
shouldn't be thinking of streaming as a standalone, something brand new, different from the way we've done data processing. It should become the standard, and batch should be a use case of that.
Well, right. I mean, back in the day, we had straight through processing, right? Isn't that what they called
Yes,
it? Is
correct.
straight through processing where you were doing real-time processing.
Right.
And to your point, batch resulted from a recognition of costs and hardware
Yes,
limitations, and we just couldn't
correct.
do it all. So we settled for little snapshots of the world. I mean, it's not as bad as just a photograph, but
Right.
it is in a way a difference between a little snippet and the whole picture. And as you suggest, the stream is the whole picture. Here's what's happening right now in totality. My big question has always been around the historical side. So you're getting data streaming at you. You have to persist something somewhere to know what
Yes.
happened before.
Mhm.
So how do those architectures typically work? What have you
Yeah.
seen?
Yeah, so this is why Kafka became so popular, because before Kafka, it was all about messaging. So message
Mhm.
passing, straight through processing,
MQ
and
series, right?
MQ series, exactly. When Kafka came out, Kafka said, oh, wait, we are log-based streaming, but we have got log persistence. And that means I can replay it. And that's very important, because in streaming, it introduces new challenges that we never had to deal with in batch. Because batch is clean cut, it's dry, and it's right there with begin and end. But what happens is, let's say I'm doing some processing. I'm driving a Tesla. It's a self-driving electric car. So I've got all these signals that somebody is processing. I go through a tunnel. All of a sudden, signal is gone. I come out. So now that data is late arriving data, or it's out of
Right.
order. These are
Right.
the problems which are very hairy to deal with. And so persistence is needed, processing is needed and this is why we've got different flavors. Am I going to process the data once and for all, and if it doesn't show up, forget about it, or I'm going to do exactly once. I want to ensure every data was processed only once. So these are the challenges that things like Kafka and other things built on top of Kafka solve for us.
Yeah. I mean, there are still challenges in aligning your topics and
Mhm.
understanding the metadata and figuring out the use
Yeah,
case. But I mean, I'll tell you the
correct.
thing that I love the most, as soon as I heard about Kafka and wrapped my head around it, which is about 10 years ago,
Hmm.
I realized this is very interesting because typically when you do all these batch processes for different departments, you wind up with all these silos. And with streaming, if you do it right, you can have one stream of, let's say, customer transaction data, and the marketing people can subscribe to that stream if they want.
Yeah,
The accounting people obviously want to subscribe to that. So anyone can subscribe to it and get it. And now you're all part of the party. You're all getting the same information at the same time. Now you need to do things differently with it. You may put different filters on it to pull out what's meaningful for you, for example, but nonetheless, you kind of solve that point-to-point integration problem, which is a mess. I mean, when you get past 14 batch windows, all of a sudden it's like, all right, now which data is going where and for what purpose? It kind of goes off the rails and
Right.
stays off the rails in a lot of these environments, right?
So actually, the point you raised is extremely important. And there's what you said is really profound. What has happened in our space is that all our attention has shifted to analytical architectures, to the right side of the equation. We talk about lake houses, ETL, ELT, change data capture. So we are taking all the streaming data and what you just said, exactly, all these pipelines, and we are munging it together and we are preparing it for consumption by downstream. But if we shift our attention to the left-hand side, the operational side, and we say, let's shift left and let's handle the stream of data as it comes in. And of course, it may need to be joined and enriched and all of that. Then we can actually ensure that downstream systems are all consuming data from the same source. In MQ series and some of the previous ones, once the message was consumed, it was deleted. But in Kafka, that message is going to stay because it's persisted in logs. And so you can, retry. So basically, by moving the downstream systems to consume data as it originates, you can shave off all this confusion with the middleware piece.
Wow. Yeah, that's such a good point because that winds up taking tremendous amounts of time and effort. And it's
Yeah.
also just very difficult and unwieldy to deal with. Now, there are other issues to handle. I mean, when
Mhm.
this kind of reminds me of doing some sort of massive government re-regulation, where
Yeah.
if you just change one thing, you're
Yeah.
never going to get there and it's going to cause lots
Yeah.
of trouble. So you have to change everything, but changing everything at once is extremely difficult. I mean, it's almost impossible. The guys from Citizens Bank were telling me it's taken them a while, but now they're like 85% in the cloud, and they expect to be
Hmm.
95% in the cloud next year. And it's all driven on a streaming architecture. So if you think through all
Amazing.
the use cases,
Yeah.
fraud obviously is top of mind. But even customer data, they mentioned right now, if you go and change your name and address in some
Yeah.
system, it takes days for that data to persist to all the different operational systems that need customer data. If you subscribe instead to a stream of customer data and you've got those log files for your persistence, that problem is solved. And they said now when someone updates their data, it's updated in seconds across
Yeah.
the entire organization. It's like, hooray. Talk about
Yeah.
customer experience. What do you think?
Yeah. In fact, if we expand the use cases to the topic du jour, which is AI, then it even makes it more interesting because let's say I in my streaming architecture like Citizens Bank or something like that, they're let's say pointing their system to a bucket in an object store in the cloud provider of their choice, and a new file comes in. I want to accept that file right away, and I want to take that. So as soon new piece of data comes in, I want to read it, chunk it, embed it, and make it available to do my RAG pipeline, my vector search, or
Wow.
or in the near future, do continuous fine tuning of models. See, right now, what happens to a model? We train the model uh, once in years, and then we say, oh, this model does amazing job, but it's out of date. So if we get to a point, which we will very soon, where we can continuously fine tune it, then it's going to piggyback on the streaming architecture because it's going to, as soon as new piece of data comes in,
Wow.
fine tune the model.
Yeah, that is very interesting, folks. And we've got a podcast bonus segment coming up here with Sanjeev Mohan of SanjMo. We're going to dive into that because I'm still trying to wrap my head around exactly what that means and exactly how that works. But it is a big deal. You either RAG, retrieval augmented generation, you work on your RAG model, or you fine tune. You can do both, obviously. But the question is when, how, why do you do those things? What are those strategic decisions? We'll be right back. You're listening to DM Radio. All right, folks, back here on a fantastic DM radio. First half was recorded in Austin at the Confluent Current event, and now the second half is with my buddy Sanjeev Mohan of SanjMo. And at the end of the last segment, Sanjeev, you mentioned this whole concept about streaming and using that to fine-tune models. So you take these models, they have billions sometimes of parameters. You don't have to have that many. You can have millions of parameters. It's really up to you. And there are different architectures to models too, many different layers. And you have inference layers, you have ingest layers, all these things are going on, and they're all different, they're all bespoke. But what's interesting is, of course, first of all, they're probabilistic. So how do you deal with that? How do you deal with the fact that they're not always going to be correct because they're converting text or imagery to numbers and then back to text or imagery? That's a bit of a lossy process. You're going to lose a little bit of accuracy on there. It's not like the old database world where you get a specific record that you want. Not that it always worked, but
Yeah.
this is a little bit different. So there is that issue. So you can either use RAG models, where you have your vector database, you populate it with all the embeddings of your corporate data to kind of weight the model towards your reality, towards the answers you want it to give, or you can fine tune the model. And I'm trying to understand exactly how that works. So from your perspective, what's the difference between fine tuning and a RAG model?
Okay, so I can answer that. So Eric, if we just talked a few minutes ago how models are tuned at some point in time or trained at some point in time, and then because it's too expensive to constantly train
Right.
400 billion parameter model, so you do it once and then so a few things happen when we do our chat GPT, like we ask questions. So there are two problems, actually two or three problems. The first problem is the data is out of date. Second problem
Right.
is it does not know anything about my own data. And the third problem is that there's some memory, how much data you can pass to it, which is a context window, which is also limited. So now with these three problems, we get into the next stage after prompt engineering, which is retrieval augmented generation, RAG. In RAG, what we say is that instead of asking the model the question for which it doesn't really have an answer, I'm going to first do a search on my own database to build out a sort of a body of knowledge that I can then pass to the LLM. So the first part is retrieval. So I've done a search, then retrieval augmented generation. So I'm going to say, Mr. LLM or Ms. LLM,
Right.
here, gotta be politically correct, here is my data. Now I want you to summarize it. I want you to tell me what's the sentiment of this data I just sent you. So see how powerful this is. So it's a combination of retrieving my own data, sending and then compressing it because the context windows are limited, and then asking LLM to do what it's really good at doing, which is similarity search, predicting what is the next word that comes in. So this is the combination of why RAG is important. Fine tuning basically says that what if I keep, like, I have a base model, it's open source like Llama 3 or Mistral or something like that, where I can then pass some of my own data and train some additional layers on top of the base, because the base so the base model already knows all the grammar. It's already been trained. It knows the basics, but it doesn't know my own corporate information. So if I can piggyback that on, then I can just use the model out of the box. I don't necessarily have to do RAG, but we are not there yet.
So it is typically a layer. This is kind of what I was getting at, right? Because you have many layers in these models, and there are all kinds of ways you can do it. You can have all sorts of inference layers, analytical layers, all these different things that come out and generate an output. And so with fine tuning, you're creating additional layers either at the beginning or at the end of the process or somewhere in the middle of the process, for example, to check and to double check. And I think that's a very good explanation, because let's face it, I'm preparing a talk right now, probable cause, a Gen AI warning, which says, hey, which part of your business can be wrong 5 to 10% of the time?
Yeah.
Sales, accounting, can accounting be wrong 10% of the time?
Right.
No, like it
Yeah.
cannot be. So this
Right.
concept of hybrid search is coming through and
Yes.
fine tuning, and you really want that last mile to be very accurate depending upon the use case, right?
Yes. So you want to reduce hallucination for sure. But there's also a very critical point. Let's say I want to run, I want to find out who are the top salespeople in my region. And that is not a good query for an LLM because there's only one right answer based on the volume of sales done. This is a deterministic query. I should write a SQL statement for that. But if I want to do more of like creative stuff, why did this person sell so many widgets in this territory of this color, of this size and this price? Like that kind of like, esoteric stuff. Uh,
Which would befuddle a SQL query.
Yes,
Right? Like,
correct.
it would just crash and burn.
Right. And if we understand, in fact, I heard this a long time ago that we humans, we are always hallucinating. Whether we've taken anything special or not, we're always hallucinating. If we
Mushrooms,
like it, then we are like, oh, this is a great answer. If we don't like it, then we call it hallucination. So
interesting.
so it's a probabilistic model. It's going to come up with what it thinks is the best answer. If that answer is up to my liking, then I'm like, wow, this LLM rocks. If it is not, I'm like, oh my God, how dare you? Yeah, so
That's funny. And I've noticed, you probably noticed this as well. And folks, email me info@dmradio.biz if you want to be on the show. But I've noticed that Google itself is now shifting between more deterministic and more Gen
yeah,
AI use cases. When you do a query, sometimes it'll give you the old answers, and sometimes it'll give you a new Gen AI answer. So it's got a bit of a sniffer on the
yeah,
front end there to go, okay, should I go deterministic on this one? Should I go
right,
Gen AI? And it kind of
yeah,
makes its mind up. And that's what we're talking about, is
right,
what you're going to see in the enterprise is a mix and match of these things, because
yeah,
I think the power of these foundational models has just begun to be tapped. We're just now
yeah,
learning about what they can do. And I think there's tremendous potential here, but leave it to Sanjeev Mohan to articulate things so clearly,
yeah.
folks. And
I
final
want,
thoughts from you, 30
yes.
seconds.
So final thought. See, today, if an LLM tells me to put glue on my pizza or how to eat rocks, I can laugh and I can ignore it. I can say, oh, here goes LLM. But we are moving into a very exciting, a bit dangerous territory of agents. These agents are autonomous. So one agent is going to call another agent. They're going to do multi-step reasoning. They're going to execute a very complex workflow. If it hallucinates, imagine that. There's no human involved, it's autonomous. So that's why we need to first fix the accuracy problem before we can let loose these agents.
That's a very, very good. This is exactly my thought too, because once and my whole question is, how are you going to manage and shepherd the behavior of these agents? Is it going to be log files? Is it going to be a hard limit on the number of transactions they can do before you check in with them? I mean, this is not a simple problem to solve,
It's
because
not.
again, they are multivariate. And if you've got a bunch of them
Right.
talking to each other, like, wait, hold on, man. That's like
Yeah.
unleashing an army of robots across the country, and you don't know
Right.
what they're going to do. So it's
Yeah. Good
very
point.
interesting. We'll tackle that on a future show. Thanks so
Sounds
much
good.
for your time today, folks. You've been
My
listening to
pleasure.
DM Radio.